Today what we're looking at is standard deviation. So it's a measure of spread. Just what are the other measures of spread we've looked at? No, mean, mode, median are measures of central tendency. What are the other measures of spread we've looked at? Range and interquartile range. So this is another one of those measures of spread, okay? It's about how the data's dispersed, which is why it's also a measure of dispersion, okay? And it's a way of sort of, you can also sort of get rid of those outliers a little bit with these, okay? So the standard deviation is the average distance from the mean of the scores. So what that means is if we looked at some different scores, so for example, if we looked at, we'll go really easy, we'll go 2, 3, 4, 5, and 6, all right? What's the mean for these scores? We should be able to quickly find the mean for these scores. It's just 4, okay? So the mean is 4. Now, if we look at the other scores, we need to know how far, or each of the scores, how far away from the mean they are. So if we look at 2, how far away from the mean is 2? It's 2 away, yeah? It's actually like -2 away, yeah? What about 3? -1. What about 4? Sorry, I'll get it back. What about 5? +1. 6? +2. Okay, so we know where all those scores are from the mean. We can work that out. What the standard deviation is the average of those numbers. Now, the problem is with the negatives is if we actually add all those numbers together, they're going to equal 0 because -2 plus 2 is 0, -1 plus 1 equals 0, okay? So we need to sort of make them into positive numbers. So one of the ways which we look at it, standard deviation is firstly called the mean deviation, which is if I just change those numbers to positives and I said, okay, 2, so this is the mean deviation, which is a little bit different. We could just say 2 plus 1 plus 0 plus 1 plus 2, all divided by 5 because there's 5 scores. So 6 over 5. And we're saying the average distance from the mean of all the points is 1 1/5. So we're averaging the distance from the mean. Does everyone sort of understand that? So we're saying each of those points is a certain distance from the mean. We average those, or we find the mean of those. That's what the mean deviation is. The standard deviation is almost exactly the same thing, but we have to put in a couple of different processes. Instead of just being able to change a negative to a positive number, we have to do something else. Can anyone think of a way which we could change a negative number to a positive number? Times by a negative number, times by -1, okay, for example. Instead of timesing by -1, what we do is we times each number by itself, because if it's a negative number, so for example -2, if we times it by itself, we end up with -2 times -2, which is +4, okay? So it's a different number, but it's a positive number. How could I then get it back to being +2? Without taking, what other thing could you do? If we found the square root of it, so we square the number, and then we find the square root at the end, which brings it back to the right number. So for each of these numbers, we square them to make them positive, and then we find the square root to get it back to where it started from, rather than just changing it, because we kind of need to have a process happening. So what we do to find the standard deviation is for each score, we find the deviation from the mean. Deviation just means distance from. You guys should be writing this down. So for our example up there, we had -2, -1, 0, 1, and 2. Okay, those are the deviations. To find this, we subtract the mean from each score. Okay, so for the first score, you've got 2. If I take away the mean, I've got the deviation, which is -2. Hang on, sorry, 4 take 4. Okay, what did I say we do to make them positive numbers? Times them by themselves. So we then square each number. So squared, 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 squared. This makes them positive. Okay, so each number's bigger, but at least they're positive. Kind of. So we've now made them all positive, but I said we had to find the average of these distances. So what do you think we mean when I say average? I actually mean the mean, okay? So I want to find the mean of these scores. What do you think I have to do to find the mean of these scores? So I need to add them all up and divide by how many scores there are. So that's our third step. Add the scores together and divide by the number of scores. This is called the variance. It's called the variance, where we've added them all together, we've subtracted the mean, squared each number, and then found the mean of them. That's what the variance is. Once you have the variance, we've only got to do one step after that. Can anyone remember what the last step we have to do is? We have to find the square root of it because we have to get it back to being that smaller number. So that number is going to be quite a lot larger than the differences. So then we need to find the square root. So last step, find the square root of the variance. This gives us the standard deviation. So you probably won't have to do this by hand too many times, okay? We're going to do it twice today, and then we need to have a look at a few different ways which standard deviation is asked in a test, okay? So you're not going to get asked to do this by hand, but you need to understand what standard deviation means to be able to answer some of the questions later, right? So we're going to together just do one by hand to make sure we understand this. So if I give you a set of numbers, find the standard, I'm just going to write stand dev, okay, of 12, 15, 18, 20, 25, 27, all right? We've got these numbers. Now, you could put it into statistics and find the answer like that, but just this once, we're going to do it by hand, all right? So first thing we need to know is what the mean is. So in our calculator, is it 19? We say 12 plus 15 plus 18 plus 20. Sorry. 20 plus 25 plus 27, all divided by 6, 19.5. Okay, that mean is really important that you know that, because all of this is about the distance from the mean. So for each of these points, to find our variance, we say 12, take 19.5 squared, plus 15, take 19.5 squared, plus 18, take 19.5 squared, plus 20, and so on. What do I have to divide it all by? Divided by 6. That gives us a number, which is the variance. It would be good if you guys tried to put this into your calculator as well, please. What'd you get? What'd you get? Oh, good. Okay, 27.583 recurring. That's our variance. Once we know the variance, the last thing we have to do is go 27.583, and we need to find the square root of that. Now, just a reminder, remember there's a cut and paste button, or for this one we can just drag and drop. So square root, drag and drop, put it in, enter 5.25. So it means that the average distance of each of those points from the mean is 5.25. Any questions about that? Okay, the sort of questions you will get in a test might say, which one has a bigger standard deviation? Which one has a small standard deviation? So I've just copied a page from your book, and we're just going to have a look at these questions. So these would have been homework questions, so it's good that we can go through them together. Is anyone still going on this page? So what's going to have, if you're looking at points, like dot points, okay, what's going to have a bigger standard deviation? Points which are all around the middle or points which are all spread out? Spread out, okay? So the more spread out the points are, the bigger the standard deviation is. But it's spread out from that middle point, okay? So even if they're all really high but close together, that means they'll have a small standard deviation, but their mean will be high. So you need to have a look at some of these dot points we're going to look at. All right, so I've just copied this page in. So for this question here, it says, I'll go back to that page later if you need to look at it. It says, choose between graph A and graph B without working out what the numbers are. Which one has a greater mean and which one has a greater standard deviation? So where would the mean be approximately for graph A? 5.5. So your mean's there. What about your mean for graph B? 8.5. All right. Now, in terms of your standard deviation, which one has more points all closer to the mean? B, okay. So the greater standard deviation, bigger standard deviation equals A, and the bigger mean equals B. Can you guys see that? These are the sort of questions you get often in a test, all right? So what about this one? The mean here would be around there. The mean here would be around here. Oh, sorry. You know where I was aiming for. It's still just as bad. All right. Still not great, but anyway. All right, so for this one, which one has the greater mean? Which one is more spread out? Okay, greater mean is B. Standard deviation? A. Okay, so just be aware, just because they're low down doesn't mean they have a greater standard deviation. Okay, last one. Actually, second last one. So, 5, so they both have the same mean. The mean's equal. Standard deviation, A is greater. Because there's more points further out. This is really important, guys. This is where people lose lots of marks. So it's important that you see that the ones further out, they're going to build that standard deviation out higher, even though the mean is still the same for both sets of data. Okay, this one's the last one. Which one has the higher mean? A, standard deviation? They're the same. There's the same. See how they're like in the same pattern? They've got the same standard deviation. Is everyone okay with standard deviation? All right, we're done.